Hello, my name is Michele Newman, and I'm honored today to be able to share our work on behalf of my co-authors and my co-design partners. Quote, I wanted to talk like Darth Vader, unquote, helping children construct creative self-efficacy with generative AI. The rise of generative artificial intelligence has prompted discussions on its potential impact on industries, education, and human AI collaboration. And while concerns like copyright infringement and bias exist, some have pointed to the potential for generative AI to create new forms of creativity. The HCI community, through the study of creativity support tools, or CSTs, has long examined technology's influence on creativity. As access to generative AI continues to grow, there is a need for understanding its role in the future of CST development. However, there can be a gap between users' knowledge and generative AI systems' expectations, especially evidenced in addressing the creative needs of children. For example, models trained on child-directed speech have been shown to differ from those trained on adult-directed language. Additionally, children's creative needs are uniquely shaped by their developmental stages and social contexts. Given the significance of the social environment in children's creative development, we argue a need to recognize the relationship that generative AI tools might play on their development and the tool's potential ability to support children's confidence around the contextual and social aspects of creativity. Therefore, we argue understanding how children engage with generative AI through the creative process and their corresponding contextual needs can help us to design more effective and context-aware systems for supporting creativity, as well as help to develop AI literacy curricula for children to prepare them for a future where technology plays an ever-growing role in their daily creative lives. Furthermore, there is also indication that creativity plays a role in learning, as creativity contributes to identity formation and cognitive development, as well as serves for a foundation of creativity that is in future acknowledged by others. Beghetto and Kaufman label these learning moments, quote, mini-C creativity, unquote, which they define as creative moments meaningful to an individual. Considering the vital role of creativity in children's development, fostering social understanding, and learning, there arises a significant question of what role generative AI might play in these moments of mini-C. In order to explore this connection between children's creative acts and generative AI, we conducted 6 participatory design sessions with children ages 7 through 13. Through the participatory design method of cooperative inquiry, a method of designing that focuses on designing with and for children, we conducted co-design activities with generative AI tools for text, visual art, and music. We aim to advance our understanding of children's creative experiences with generative AI through exploring the following research questions. How do children in co-design workshops perceive generative AI tools and their usage for creative works? And how do children navigate the creative process while using generative AI tools? And how might these interactions support their confidence in their ability to create? Research within HCI has shown that PD techniques like cooperative inquiry allow children to more concretely express abstract, sensitive, and complex ideas. The co-design group Kids Team UW consisted of both adult design researchers, such as investigators, master's students, and undergraduates, as well as 12 child participants. All children had parental consent and child assent. The university's Institutional Review Board for Ethics approved all research conducted. Participants engaged in 6 90-minute design sessions over the course of 4 months from February to May in 2023, and each design session consisted of snack time to build relationships with children, circle time, a warm-up activity in which we ask a question of the day to help adults and children get ready for the design activity, design time, and finally, discussion time, where groups present their final designs and the whole team reflects on the design experience. We recorded all of our sessions via Zoom chat on 3 to 4 computers, depending on the number of design groups, and we collected a total of 16 hours and 30 minutes of video. The researchers also collected the designed artifacts of the sessions via screenshots if they were digital and pictures of analog. We employed a combined inductive and deductive qualitative approach, which is further detailed in our paper. Design session 1 included asking children to experiment with ChatGPT, noting likes, dislikes, and design ideas. Session 2 furthered this by asking children to use comic boarding to explore good and bad uses of ChatGPT. Next, we asked children to write creatively with ChatGPT, again prompting additional ideas with likes, dislikes, design ideas. In design session 4, we switched to visual tools, asking children to evaluate using Dalla, noting their likes, dislikes, design ideas. And in design session 5, we asked children to create storybooks using Dalla and ChatGPT, and then share out their stories and experiences at the end of the session. Finally, we asked children to complete 2 activities in Design Session 5 aimed to get an understanding of their experience with using AI tools to create music. Ultimately, children in our study perceived generative AI tools as capable of producing creative outputs, but required external assistance, either from adult co-designers or peers, to develop a mental model that supported the tool's creative uses. More specifically, we identified 3 factors that were influencing a child's mental model. In our study, children grasped how generative AI worked by comparing their expectations with system outputs. They observed that generative AI frequently combined pre-existing content to generate responses, exhibited repetitive behaviors in these responses, and had the capacity for learning and adapting through interactions. Another factor evolved as children shaped their mental model of generative AI by comparing it to other technologies, such as Google search engine. On the bottom right of the slide, there's an example from Design Session 2 that reads, quote, panel 3, how would you use ChatGPT, unquote, in regards to one of the children working on a comic board about bad uses of the tool. Under the question, they write, quote, how do I know if a kid is scamming people with a lemonade stand, unquote, suggesting that children build their mental models based upon other familiar information-seeking technologies. Lastly, children had a tendency to apply a general mental model to individual tool-specific affordances. This suggested that encouraging children to reestablish their model of generative AI as a tool with a specific purpose can help them to form a more accurate mental model. Despite children's increasing understanding of how these generative AI tools functioned over the course of our study, they frequently encountered moments of frustration when the tool's outputs did not align with their expectations, resulting in issues with the goal of evaluation. When children felt the tool did not meet their expectations, they would engage in one of 3 behaviors, including rephrasing the prompt, adding on context to the prompt, or completely pivoting to a new idea. If the task or topic was something a child liked, they were more likely to engage in the first 2 behaviors. These findings reveal that children go through a process of trial and error when using generative AI for creative tasks, and these iterations are marked by evolving comprehension of both what the tools can do, as well as readjustment to the children's description of their creative goals. Children in our study also noted that the language of generative AI systems seemed, quote, formal, unquote, which could lead them to misaligned or frustrated interactions. Children had more successful experiences when they were able to use language that closely aligned with their interests and understanding of specific domains, such as one child asking ChatGPT to talk like Darth Vader. Lastly, children also showed preferences for certain mediums of creation over others, which impacted their choice of tool and their final creative product. Children's perceptions of generative AI for creative works was also influenced by the framing of the creative task, indicating a relationship between the nature of a task and their ability to express creative intentions. Notably, when children could align the task with their creative interest versus one that was supplied to them, there was a discernible shift from information seeking to expressing their own creative ideas. In addition to personal creative intentions, ethical considerations also played a role in how children engage with generative AI tools. When engaging with situations involving personal creative endeavors with the tools, a more introspective dimension surfaced as a determinant for their ethical considerations. When prompted about their opinions about a friend utilizing ChatGPT to compose a birthday card, for example, responses were contingent upon contextual nuance, such as how much of the card was written by AI. These discussions highlight the multifaceted nature of children's engagement with generative AI, emphasizing the need for nuanced conversations in both educational and personal creative contexts. Ultimately, our findings coalesced in an explanatory model of context for supporting child generative AI creative interactions. Our model centers around mini-C moments, a concept again borrowed from Beghetto and Kaufman. And these moments, not requiring external recognition, are crucial for learning and lay the groundwork for later creative ideas and confidence in one's ability to create. The next layer, supporting context, identified the 4 contexts that we found within our findings. Arrows indicate the dynamic relationships between these contexts and mini-C moments. The last layer and the outermost layer, scaffolds, are placed around these contexts to signify the observed actions enhancing these specific contexts during our design sessions. Each section contributes to the overall experience of mini-C moments, like a slice of pie, emphasizing the main takeaway from our findings. The first slice of pie is the context of system affordances. This context encompasses the relationship between a child's capabilities and the properties of a specific tool utilized. It encompasses the understanding of the system's capability and the child's awareness of the system's capabilities. This context can be supported by code switching as well as transparency of why specific creative choices are being made. Importantly, due to this relationship, this can happen at both the level of the child as well as the system. The second slice refers to children's processes, encompassing a multifaceted set of skills, including the ability to establish the creative task at hand, gather relevant information based on personal interest and existing knowledge, generating the outputs and evaluating them based on the provided task. Furthermore, it entails the capacity for flexibility, as the process of creating is dynamic. It may be supported by helping children to explore and understand their own personal interests and personality, as well as developing coping mechanisms for using certain systems. The third slice is domain understanding, or establishing a structured framework of norms, expectations, and shared understanding within a given culture or community context. Helping to support domain conventions and domain-specific thinking can support this context. The final slice is creative intention, supported by the environment, whether that's formal or personal, as well as the ability to describe the specific creative goal. Furthermore, we suggest a connection between a system affordances and the social environment, based on a comparison of our model to Amabel's componential theory of creativity. This framework argues that the mechanisms of social environmental factors impact an individual's autonomy, competence, and task involvement, both in positive and negative ways. This implies that generative AI systems serve a dual role as both a creative collaborator, assisting in solving creative tasks, and a potential element that can influence a user's experience of these aforementioned factors. As generative AI has this influence on the social environment of a child's creativity, we believe it shows potential as a constructionist educational tool. In particular, we believe that there is potential in its role as a constructionist tool for teaching creative self-efficacy. This is an individual's belief that they can complete a creative task in the role or given situation. Through identifying sources of self-efficacy from the work of Bandura and Maddox, and comparing them to our context, we created a set of questions and a chart. On the left side of the chart, from top to bottom, are the sources of self-efficacy, including performance accomplishments, vicarious experiences, verbal persuasion, emotional state, and imaginal experiences. Along the top row include our context of affordances, process, domain, and intention. Where each of these meet is a question aimed at supporting both the context and this particular style of supporting self-efficacy, such that the performance accomplishment and affordances pair, for example, raises the question, how well did the interaction capture the essence of my prompt? What sets generative AI apart from other types of constructionist tools of learning is the quickness it provides in allowing children to turn creative experiences into moments of mini-C. Generative AI takes on this role of creator, potentially encouraging children to consider their larger creative intentions and experiences if scaffolded correctly. In our paper, we further explore the application of these questions by looking at an interaction where one child tried to write a sad poem about rocks with ChatGPT. Ultimately, our study investigated how children perceive generative AI tools and navigate their relationship with these tools in creative experiences. It shows that children construct knowledge, adapt their creative processes, consider knowledge of domains, and are influenced by creative tasks and their environment. Furthermore, it shows a link between the design of generative AI systems, children's individual abilities, and the domain of creation. And while our work is based on the creative experiences of children, the model presented in this paper could be applied and adapted to help explain other populations as well. For though the scaffolds may change based on expertise, our findings suggest that these contexts can be used to understand other creative experiences of those who are incorporating generative AI tools into their own creative processes. Finally, we argue a generative AI tool is a tool to support creativity, not a replacement for creating. It should be noted that there's no stand-in for children developing their knowledge of a domain or creative technique. Our findings contribute to ongoing discourse on AI literacy, creative support tools, and constructionist learning, offering valuable insights into the way generative AI can empower individuals to explore their creative potential and build creative self-efficacy within a rapidly evolving technological landscape. We encourage you to further reach out if you have any questions. Thank you.